All right, so can you hear me? And can you see my screen? Well done. So what I want us to do to talk about, remember, I want us to be able to answer this type of questions. We are going to be pushing through important questions that you find in the past paper, okay? I want us to answer all these type of questions that you ever get from a past paper that say factorize, and then you get some stuff like this. Can you see it? Can you see it saying factorize, then it gives you situations? I want you to always know what to do when you're in a situation like this. Remember, look at this, Alex. This is in October, November 2025 paper. So this is from last year. Can you see that? October, November 2025. So that is here, October, November 2025. So this is a last year type paper. So this question can come. Okay, make no mistake about it. These type of questions do come. So I want us to be able to answer them, because you can see I have a lot of them. We've got a lot of them. You can see it came in October, November 2025. We can even open another one from March 2025. Look at this. February, March. This one is only written in India, but it's still last year. Can you see where it says factorize, then it gives you something? Can you see? So factorization does come, okay? And it can also come when they ask you to solve an equation. We're going to get to that type of question. I want us to always know what to do. What do we do in this situation? We should always know. What do we do? What about in this one? What about in this one? I want us to always know what to do. Are we together? Right. So here's how we're going to be doing it. Are you seeing, Alex? Right. We want to do, so this is, we can say what we're going to be going through together as a team today, Alex, is factorization start to finish. We want to master, and we'll be using questions, a lot of questions we discuss together until we can do them together, right? Start to finish. So, Mr. Clarify, how do I know when I'm done with factorization? Like, can you give me a picture of factorization? Here is how you know you're done. Factorization has 4 methods. So for you to know you're done with factorization, you must know that you are good at all 4 methods. Are we together? So let me put the fourth and final method, then we talk about them. There's factorization of quadratic trinomials. Here, quadratic trinomials. Right, Alex, look at this. There we have 4 ways of factorizing, and if we know those 4 ways of factorizing, we are done with factorization. We can go to the next concept. Are we together? We have 4 ways of factorizing, and when we are done with it, we can be able to go to the next concept, because factorization will be done. Okay, can you hear me? Are you sure you can hear me? Okay, so give me 1 second. So we have 4 ways of factorizing. I want you to be good at all 4 ways of factorizing. Wait, give me 1 second. Give me. Give me 1 second. I want to continue with you. Just want to fix this setup. Okay, wait. Right, can you still hear me, Alex? Right, let's go. So, what did we say you should do when you're doing factorization? We said you must know that you have 4 methods, right, Alex? How many methods do you have for factorization? Alex? Hello? Well done, I like that. So that is, you should know this, Alex, that, okay, when you're doing factorization, the first thing you must know is that you must know all 4 methods. This is how you know you're going to. So we're going to be doing questions, right, Alex? We're going to be doing questions one by one until we are good at all 4, okay? What is the first method? I want you to, here is how you're going to master factorization, Alex. Here's how you're going to master factorization. You are going to, here, you are going to look at the situation that you have been given. Can you hear me? You're going to, Alex, can you hear me nicely? Okay, good. You're going to look at the situation you're given. Then we're going to see which method does it want. Does it want by grouping? Does it want by, I don't want you to say completing the square, sorry. It's difference of 2 squares. Can you write this down? Isn't you going to send me the notes when we're done, right? You're going to send me this note. So go for it. Write difference of 2 squares. So we have finding the common factor. We have by grouping, Alex. This one you only do it when you have 4 terms. If you're given 4 things, I'll go to a question where you're given 4 things and show you. When you're given 4 things, you factorize by grouping. Can you hear me? Are we together? When you're given 4 things, this one is easy. There's only one way you can factorize. It's by grouping. So let me go to a question and just show you from a past paper. I think it was the one I opened first. Let me go to it. Let's see. This one? Is it this one? No, it's not this one. Wait. Let's go to it. I think it's this. Right, Alex, can you see this one? Are you seeing this question? What does it say here? It says you must do what? What does number 15 say we must do? Here? It says we must factorize. And can you tell me B? Can you see what B does? How many things are on B here? How many terms do we have? We have 4 terms. We have 4 terms. So what method do we use when we have 4 terms? We have only one method to use. It is by grouping, right? We factorize by grouping, which means you look at the first 2 terms on their own, then you look at the last 2 terms on their own. Okay? Then you factorize like that. So this one is easy, this one. This is by grouping. I want you to be able to look at the situation you have been given. Then you should tell me what situation you've been given. Okay, Alex? This is how you see. We have only 4 types of situations they can give us. We want to master all 4 situations, and we're going to be doing a lot of questions. In here, this one is going to be the 4th and final one, the last one we're going to do, where you're going to get something which has 3 things, and it's quadratic. What is the highest power of x here, Alex? What is the power of x on 7x? It is x, which is x to the power of 1, right? The power of x is 1 here, right? What about here? What's the power of x here on this first term that I'm pointing in black? What is the power of x there? Power 2. So which one is higher? Power 1 or power 2? Power 2. So if power 2 is the highest power, that means you have something which is quadratic. Okay, Alex? So this is quadratic. You just look, you see x squared there. This is a quadratic, and it has 3 things. So this is the quadratic trinomial. Okay, Alex? What is this? This is the quadratic. This is the quadratic trinomial, right? Well done. You're doing good. You're doing good. Push, push, push. This is the quadratic trinomial. So what we're going to be doing, look at it. We go back to our methods. How many methods did we say we have that we got to do? Start to finish. 4. Well done. We've got 4 methods that we got to know start to finish. What is method? The first method? We're going to be factorizing by finding what? The first common factor, right? finding the common factor. So it's going to be a basic term, just an ugly term. Things mixed up. It's just going to be an ugly term. Things that are going to be mixed up, whether they're adding or subtracting or whatever. There could be two things, there could be three things, but they're just mixed up. Here we are going to just factorize by finding the common factor, right? So we're going to talk about that common factor. Then what is the second method? Read it out loud. What is the second method, Mr. Alex? Factorizing by grouping. And for this second method, we use it when we have how many things? When we have four things. So this one is specific when we have four things. In the first one, by finding the common factor, we use it when we have what? When we have ugly terms, right, Alex? We use it when we have ugly terms. So when we see ugly terms, what method are we going to use? Method number one. When we have ugly terms, things that are ugly, haphazard, just adding and whatever. What about this method number 3? It's for a special type of situation. It's by finding what? What are we going to be finding? Can you read it out loud? Difference of two squares. So you're going to have two square numbers, right? You're going to have square numbers, right? So this is a specific one. When do we use this method number 3? You're going to have square terms, square numbers or square terms doing what? Subtracting, because it says difference, right? So when you have squared numbers, we're going to talk about them to say what are square numbers. When we see them subtracting, then we use method number 3. Can you see that method number 3 has a specific situation where it's used? Can you see that? Method number 2, can you see that it has a specific situation where it's used? Can you see that method number 4 has a specific situation where it's used? Something which is quadratic, eh? Something which is in this form, ax squared plus bx plus c. Can you see this, Alex? There will be an x squared something, then there will be a something with an x, then there will be a something plus c. Let's just say, for example, x squared minus 7x plus 6. Or let's just say, for example, another one, Alex, 5x squared plus 3x. I'm just giving an example plus 4. Can you see this, Alex? What do you see here? What is this? This x squared plus what? What is special? What do you call something which is like this? It's called a quadratic what? Alex? Quadratic trinomial. Like this. These are the quadratic trinomials. Can you see quadratic trinomial, the word? So I want you to get used to it. So look, I want you to get used to these three. The easiest way for you to master this chapter is if I show you everything, okay? Then we start pushing them one by one. Are we together, Alex? We have to master everything, then we start pushing them one by one. So here, how many methods did we say we have? Just remind me again one more time. Okay, great. We have 4 methods. Wait, give me a second. Give me a second. Okay. Can you hear me? All right, good. So I was saying we have 4 methods, right? What are the 4 methods? Tell me one more time, Alex. I want us to keep repeating. Okay, maybe let's write them without looking. I want us to keep repeating this part before I do. We have 4 methods of factorization. Can you do me with me? The 4 methods of factorization. We want to talk about yes, the factor of factorization. What is method number 1? We factorize by doing what? Well done, well done. Factorization by finding the common factor. By finding the common factor. We're going to learn this method. When do we use this method? Factorization by finding the common factor. When we have what type of thing? When we just have ugly terms, right? There is nothing special about them. They'll be just mixed up. Isn't Alex? When you have ugly terms, you use this method. What is method number 2? Factorization by what? Yes, well done. Factorization by grouping. Well done. Factorization by grouping. We use it when we have, it's only used in one situation. Well done. We only use it when we have 4 terms. We only use this method when we have 4 terms. Then let's go to the third one. This is going to be the third one. It's going to be factorization by what? Yes, factorization. No. We changed it. Factorization by difference of 2 squares, okay? It's no longer completing the square. That was a mistake. Say difference of 2 squares. Factorization by difference of 2 squares method. It's a method by the difference of 2 squares method. When do we use this? When do we use this? When we have, number one, we should have square numbers, right? We should have square numbers. And what should the square numbers be doing? Should they be adding? No. Well done. The square numbers should be subtracting, right? Square numbers subtracting. For example, I'll just give you an example, although we'll talk more about it. For example, if you're going to have something like this, like 4x squared minus 9, okay? You're going to learn that 4 is a square number because you get it when you say 2 times 2. X squared is a square number because you get it when you say x times x. 9 is a square number because you get it when you say 3 times 3, right? So here we have a square number, a square number, a square number, and they are subtracting. So we only have square numbers in this question and they are subtracting, so we use difference of 2 squares method, right? Then let's put the final one. Let me do this. Let me add a page. Then let me put it at the bottom here. All right. Then what is the fourth and final way of factorizing, Mr. Alex? Factorization by what? We have done factorization by grouping. We have done factorization by finding the common factor. We have done factorization by difference of 2 squares. Then there is the last one which comes a lot, factorization of what? Yes, quadratic trinomials. Well done. Quadratic trinomials. Things that are quadratic, right? Like for example, x squared plus 5x plus 6. That's an example, right? Another example, well done. Well, let's say for example, they say another example, 2x squared plus 7x. 2x squared plus 7x plus 5. Here's another example. So in here, you have to factorize by using the method that you do when you do quadratic trinomials, okay? This you can see it as an x squared, here it is an x squared, and there are 3 things. So there is a method that we use here which you must be familiar with. Are we together so far? Well done. Well done. You're doing well. So now let's start questions and we'll be doing method by method. And I want us to look at the situation, then we talk about what method to use, then we apply it, okay? So for the first, we're going to go through this worksheet. It's not my worksheet, it's somebody else's worksheet, but I like it, so that's why I'm going to use it. It has questions that look like the ones you would meet in an exam. So this is amazing. So let's just go through it and let's see how it goes. I love it. Are you ready to go through the questions? All right, great. Let's go through the questions. Here's the first one. Here's the first one. I'm going to be using, we're going to be just doing questions that have method number 1, that use method number 1. Okay, look at this type of situation. They said factorize, right? Look at this one, Alex. Is there anything special about it? Does it have 4 terms? Does it have 4 things here? Okay, so it's 2 things. So factorization by grouping is out, right? All right. Is it a quadratic trinomial? Is it a quadratic trinomial? Do we have 3 parts here? So it's not a trinomial, okay, and it's not quadratic, so it's out. Do we have 2 squares? Do we have square numbers only? Is 15 a square number? Can we multiply anything by itself to give you 15? No, right? And this p is not even a square number. It should have been a p squared. This t is not a square term. It should have been a t squared. So the squares are out. So that means by grouping is out, right? Factorization by grouping is out. That means quadratic trinomial is out. That means factorization by difference of 2 squares is out. So this is just an ugly term, right, Alex? This is just an ugly term. There's nothing special about this term. So we use what method? The common factor method, right? So let's do the common factor method. That's the only way to factorize this one. It's an ugly term, so the only way to factorize it is by using the common factor. So let's put it, we'll say, okay, we have 15p squared, then we have plus 24pt. We want to factorize. So let's use the common factor method. Let's see how it goes. Let's use it, and let's use it well. Right, what happens here? The first thing, how do we use the common factor method, Alex? First, we look at the numbers. Common factor method says, look for a number that is common, then you look for a letter that is common, right? When you're factorizing. So let's look for a number that is common. What number do we know that can get into 15 and 24? You start at 1, then you go to 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. By the time you get to 9, you should have. We can start from 9 going back. Does 9 go into 15, Alex? If you say 15 divided by 9, do you get a good answer? So it's out. 15 divided by 8, do you get a whole number? So it's out. 15 divided by 7, do you get a whole number? So it's out. 15 divided by 6, do you get a whole number? Okay, so it's out. 15 divided by 5, do you get a whole number? What is the whole number? 3. All right, now 24 divided by 5, do you get a whole number? So it's out. 15 divided by 4, do you get a whole number? So it's out. 15 divided by 3, do you get a whole number? 15 divided by 3? Oh, great. What about 24 divided by 3? Yes. Oh, good. Yes, you do get a whole number. So for this one, 24 can go into, do you have your calculator with you? Okay, let's use it. So 3 can go into 15, 3 can go into 24. This is our answer, okay? The first number, you just list them and you go like that. Now let's see, do we have a letter which is common? Is P also here? Do we have P which is, yes, P is there here and P is there here. Right, Alex? We have a letter which is common and it's P. Now, which P do we take? When you have a letter which is common, you take the lower power, right? So which one is the lower power? We can see P is common, but here it's a P to the power 2, here it's a P to the power 1. Which power is common? Which one is lower? P to the power 1, so that's the one we take. And there's no other number which is common, so we can now open our brackets. What is 15 divided by 3? What do you get? We get 5. Then what is P squared divided by P? You have 2 P's, you remove 1 P, you remain with 1 P, right? A P, isn't it? Then we now say plus, since this one was a plus. What is 24 divided by 3? Can you do it? 24 divided by 3, what do you get? You get 8. Well done. Then what about P? You remove another P. They cancel out, right? What about T divided by P? Is it common? No. There is no other T, so the T comes just like that, okay? Because there is no other T. So can you see what you do here? You now write your final answer. 3P multiplying 5P plus 8T. Which method are we using here? Which method are we using, Alex? Yes, the one where you get ugly terms. So it's the method of common things, where you find the common things, common factor. Let's see here again, factorize completely. Is there anything special about this? Are these 4 terms, Alex? Are these 4 terms? No. These are not 4 terms, right? Okay, is it a quadratic trinomial? Is it a quadratic trinomial? It's not a quadratic trinomial. Okay, so that's out. What about, is it, do we have do we have square numbers only? Square terms? No, we don't. 3 is not a square number. U is not, it should have been a U squared. The V should have been a V squared. So we know that if we are talking about square numbers, it's 1 times 1 is 1. So 1 is a square number. 2 times 2, 4. 4 is the next. 3 times 3, 9. 9 is the next. 4 times 4, 16. 16 is the next. 5 times 5, 25. 25 is the next. 6 times 6, 36. 36 is the next. 7 times 7, 49. So we should be having these type of numbers. 64. We should be seeing them, right, Alex? If it is made up of square things only. But here, that's not the situation. We have a 3, which is not even there on this list and whatever. And we should be seeing U squared and V squared. So this is nothing. It doesn't have 4 terms. It is not a quadratic trinomial. It is not, it doesn't have square things that are square. So that means this is an ugly one, right, Alex? This is another ugly one. So we do which method? Method of finding the common terms, right? That's the method we're going to use for this one. We do the method of finding the common terms. So let's do that method. Let's find the common terms. We rewrite it. We rewrite it to say 3uv plus 9vw. So that's the only way we are going to factorize it, by finding the common terms. We start by finding the common, a number which is common, then we'll find the letter which is common. Are we together? So let's put the numbers. We say 1, 2, 3, 4, 5. We don't even need to go to 4 because there's a 3 here. So we end at 3. Can 3 go into 3? Yes. Can 3 go into 9? 3. Okay? This is going to be, yes, it can go into 9, it can go into 3. So that's the number we're going to pull out. We pull out a number which is common. Let's go to the letters. Is U common, Alex? We only have U here. We don't have it here, right? Remember, we start with the numbers, then we do the letters. So which letter is common? V. Is it there here as well? And what is this lowest power? It's just 1, right? It's just a power 1. All right. Now we can open our bracket. We have everything. 3 divided by 3. They cancel, right? Okay, good. What about, Alex, if 3, we have 3 and U. What about U? Is U going to be divided by anything? No. So it comes, right? V and V will cancel, right, Alex? So U will come as it is, but V will cancel. Then we say plus. What is 9 divided by 3? What do you get if you say 9 divided by 3? What is it? What is 9 divided by 3, Alex? Yes. Okay, good. So it's 3. Then the V, it cancels with this V, which is outside, right? Then what do we remain with? The W only, right? Good. So this is what you'll be having. Can you see what you have now? Okay, so this is going to be 3V multiply U plus 3W. Are we together? Let's look for another ugly one. Here, Alex. Next question. Factorize completely. Can you see this? All right, let's factorize this completely. Can you tell me, is there anything special about this term? Does it have 4 terms? Okay, so factorization by grouping is out, right? Is it a quadratic? Well done. This is an ugly one, so we have to do the common factor method. You see, you're getting there. That's what I like. Well done. This is another ugly one. There's nothing special. Things are all mixed up. We have an x, we have an x squared, we have a y, we have nothing. So we don't have, if it was a quadratic trinomial, we know what it would be like. Eh? It would be something with an x squared, then something with an x, then a number, right? And adding, right? Or it could have been 4 things like here, or it could have been nice square things, you know, where you have an x squared and you have a y squared, everything is squared. But that's not the situation here. This is an ugly one. So we used the common factor method. Well done. What does the common factor method say, Alex? What is the first thing you do? What is the first thing you factor out? What is the first thing you bring out? The common what? Yes, you start with the numbers. You see which number is common. So since here there is a 3, that means if we look for common numbers, we end at 3. Okay? Which number? Let's start with 3 here. Can 3 go into this 3? Yes, it can go. Can 3 go into 12? 12 divided by 3. Do you get a whole number? Do it. Let's see. Do you get a whole number? Did you say 12 divided by 3? Okay, great. So that means the number we bring out is 3, right? It can go into 3 and it can go into 12, right? Now, which letter is common? We've done the common number. Which letter is common? Which, like the letter now? Yes. Which X? X is common on both. It's there on both. And what is the lower power of the common guy? What is the lower power of x to the power 1, which is just an x? Well done. So when you find a common letter, you take the lower power, which is appearing. If it was 2 and 3, we would take power 2. If it was 3 and 4, we would take power 3, right? We take the lower power. Now let's open our bracket. What is 12 divided by 3, Alex? 4. Well done. X and x will cancel, right? What do you remain with now? A y. Then minus. What is 3 divided by 3? Nothing, right? 1. Yes, but you don't have to put it. X, 2 x's. You have 2 x's here. You remove 1. You remain with 1x, right? With an x. All right, good. So this is going to be what you have. So you write this as your final answer. 3x multiplying 4y minus x. Are we together? Can you see how it's going? Can you see the ugly ones? Okay, so are you confident that the ugly ones you can do? We'll come back to this one where it's 4 things. Eh? Let's look for another ugly one. Look at this one, Alex. Is there anything special about this one? Can you see it? Okay, it's just an ugly one, right? Because it has a w and a w cubed. So how do you factorize it? Yes, you have to find the common factors, the common terms, right? Okay, well done. So w and w cubed. So what is common here? Do we have a number that's common? No, it's just a 1. Which letter is common? Do you have a letter that is common? W, right? What is the lower power there between 1 and 3? What is the lower power? 1. So we just pull out the w. Okay? Then what is w divided by w? What do you get? If it's the only thing there, what do you get? It will be 1 plus, what are 3 w's? You remove 1 w. How many will you remain with? Alex? You have 3 of them, you remove 1 of them. How many w's will you remain with? 2, which is a w squared, right? Well done. So this is going to be what you get. Can you see? So you're going to say it is going to be w multiplying 1 plus w squared. Can you understand now? Can you see what's going on? Are you sure? What about this one? They say factorize completely. Tell me, what type of a term is this one, Alex? What type of a term is this one? Yes, yes, we use the common factor method. But what type of a term is this? Is this a quadratic trinomial? No, it's not. Quadratic trinomial would have been like x squared plus 5x plus 6, right? Yes, yes, this is now 4 terms. Well done. The one below it is 4 terms. Well done. So the one below it is 4 terms. So what method do we use on this one below it? By grouping. Well, by grouping, right? When we have 4 terms, we said we use the method of what? Factorization by grouping. Well done. When we have 4 terms, we use factorization by grouping. Okay? So here we have 2 terms and they're ugly terms. Is this not an ugly term situation? Good. So now, in ugly terms, how do we factorize them? Because we have a squared, we have something which is not squared like that. So how do you factorize 4p squared q minus 6pq squared? How do you factorize it? Yes, you look for the common terms. Well done. When you look for common terms, you start with what? Do you start with the letters or you start with the numbers? You start with the numbers. Which number is common here? In 2 and 6, you'd say, yes, 4, 3, 2, 1. You're right. We try with 4 because we use the biggest number, which is like with this one. 4. 4, can 4 go into 6? No, it's out. So this is out. What about 3? Pardon? Okay, yes, but can 3 go into 4? No, so it's out. What about 2? Can 2 go into 4? 4 divided by 2? All right, good. What about 6 divided by 2? Can 2 go into 6? All right, so good. So now what we're 2 can go into both. So we're now going to pull out the 2. Then what letter do you see on both? What letter do you see? We see a P, right? Can you see the P? But here it's P squared, on the other one it's P. What is the lower power, P squared or P? P. So we'll pull out a P. Is it there another letter which is common as well? The Q, right? Okay. So what is it now? Here, what is the lower power between Q to the 1, which is just this Q, and between Q squared? Which one is the lower one? Just Q itself. Well done. So now let's divide. Let's do the divisions, Alex. Well done. Now you're doing it very well. What is 4 divided by 2? You get 2. Well done. What is P squared divided by P? You have 2 P's, you remove 1. What do you get? You remain with the P. What about Q? You have 1, then you remove it. Pardon? You remain with the Q. Here on Q and Q, they cancel, so there's nothing left, right? All right, so we now put our minus. We say now, what is 6 divided by 2? 3. So it's going to be 3. What is P divided by this P? So what is it? P and P, do we have anything remaining? They cancel. Well done. What about for Q? You have 2 of them. You are removing 1. Okay, you just remove minus 1. So good, because you have 2 of them. You remove 1, you remain with 1, which is like this. And then now, that is what we'll put. It will be 2. So let's put it 2PQ multiplying 2P minus 3. Can you see? Is this hard? Okay, what about this one? What type of a term is this? Okay, how many terms do we have? On this one. 15a cubed plus minus 5ab. How many terms do we have? 2 terms. Good. So is grouping in there? Can we do by grouping here? So we cannot do by grouping, right? What do we use? The one for finding the common factor, because this is an ugly one, right? All right, so this is an ugly one, so help me to do the finding the common factor method. What do we do? We rewrite it. Okay, well done. Rewrite 15a cubed minus 5ab. Then what do? You look for what? So here we would say, yes, what is it? What number can go? Any common number, I like that. What number can go into 5 and 15? Okay, it's 5. Oh, okay, that's good. You already know. What about, is there a common letter? What is the common letter A? What is the lower power of that common letter? All right, so it's going to be A. So now we would say, because that's the lower power, you see that a is common. You don't take a to the 3, you take a, which is the lower power. Now you can open your bracket. What is 15 divided by 5? 3. And what is a cubed divided by 5a? Yes. What is a cubed divided by a? You have a cubed, you divide an a. You have 3. You have 3, you remove 1. How many do you left with? Yes, a squared. Then now you put your minus, this minus. 5 into 5, 1. Then what about a divided by a? What do you do? Okay. Well done. So it's just going to be b. Because a and a will cancel. So this is going to be your final solution. Look at how easy it is. 5 multiplying 3a squared minus b. Okay? This one is 4 terms, so when we factorize, we're going to use the by grouping. But we want to start with the things where you don't use by group. Look at this one again. How do you factorize this one? So we write it down. Well done. We write it down again. 9x squared minus 6x. What is the first thing we do? We look for what? This is an ugly one, right? Yes, this is an ugly one. There's nothing special. Pardon? Yes. Look for a common number, then you look for a common letter. What number can go into 6 and 9 without leaving a remainder? 3. 3 can go into 6 and 3 can go into 9. What about on x squared and x? We put the x, right? So now you say, what is 9 divided by 3? 3. Then what happens when you have 2 of them and you remove 1 of them? You remain with 1. What would be the next thing here? You'd say, yes, it's an x. That is the what is, you said 3. It would be 3. Then x, you have 2, you remove 1. What do you remain with? X. Then you put your minus. Well done. Well done. 6 divided by 3? 2. Then the x and the x will cancel. So it's going to be like that. So you now have 3x multiplying 3x minus 2. So on this method, are we good? So on the method of finding the common thing, are we good? Are you sure? Even if you get it as 3 things, you're good? So on this method number 1, we are doing well so far, right? Okay, look, don't let them fool you here. What about on this one? It almost looks like you have square things, okay? Be careful. When you see square things subtracting, you don't use the ugly method which you have been doing. But here, Alex, 3 is not a square term. You don't multiply anything by itself to get 3. Do you understand? We know that we multiply 1 by itself to get 1. So 1 is okay, it's a square term. We know that 4 is okay because you multiply 2 by itself to get it, so it's a square term. We know that 9 is okay because you multiply 3 by itself to get a square to get it. We know that 16 is because you multiply 4 by itself. We know that 25 is okay because you multiply 5 by itself. You know that 36 is okay because you multiply 6 by itself. You know that 79 is okay because you multiply 49 is okay because you multiply 7 by itself. 64 you multiply 8 by itself. But do we see 3 and 12 on this list of square numbers? No, we don't. So that means we are going to use the ugly method first, right? All right, so let's rewrite it. So it's going to be 3a squared minus 12b squared. Now tell me, what is the first thing you do here when you are using the ugly method, Mr. Alex? Yes, what number can go into 3 and into 12 without leaving a remainder? 6 into 3, can it? 3 itself. Well done, 3 itself. All right, so what is 3 divided by 3? That's 1. You look for a letter which is common and it's not there, so we can open our bracket, right? What is 3 divided by 3? That's just 1, right? What about a squared? Can it be divided by 3? No, so it just comes as an a squared, right? Then you put your minus, this minus. What is 12 divided by 3, Alex? 4. 12 divided by 3, this is 4. What about b squared? Can it be divided by 3? So it'll be like this. So you have factorized. Can you see this? But I want you to then notice something. Look inside this. What do you see? What do you see if you look inside? We now have a situation which we talked about a little bit. This is a square term. Do you agree with me that a squared is a square term because it's a times a? Do you agree with me that 4 is there on the list of square numbers? So it's a square term. It's 2 times 2, right? Do you agree with me that b squared is b times b? So it's a square term. All right, because square terms are the answer that you get when you multiply a number by itself, right? So now we can then factorize this inside, Alex, using the difference of two squares method. You can see that these are squares and they're subtracting, so you can use the difference of two squares. Difference of two squares says if you're factorizing this something like this, x squared minus maybe minus 9y squared. Do you know what you do, Alex? You see, oh, this is a square number, x squared. 9 is a square number, it's there on the list. Y squared is a square number. Can you see that? And they are subtracting. You only do this when they are subtracting. Are we together? Are we together, Alex? They have to be subtracting. So you know what you do? You remove the squared, you square root them. So what is the square root of x squared? It's just an x, okay? You remove the squared. What is the square root of 9? It's just a 3. Square root means what number do you multiply by itself to give you 9? You understand? Square root of 9 is a 3. What is the square root of y squared, Alex? Square root of x squared is x, right? Square root of 9 is 3. What about the square root of y squared, Alex? Yes? What is it? Square root of y squared. This one, this part. What is the square root of a y? Of an x squared is just an x, right? You throw away the squared. What about square root of a y squared? You throw away the squared, it just becomes a y. Yes, well done. So now what you do when you are factorizing things that are like this, x squared minus 9. Here is the method. You square root each of the terms separately down here. Then you make two brackets. One which says x plus 3y, then x minus 3y. Okay? The x and the 3y. One to be saying plus, the other one will be saying minus. Okay, Alex? So look at this one. Can you see the a squared? What is its square root? It's an a, right? And can you see it as a minus, which is good? What is the square root of 4? You can punch in the calculator to say, what number do you multiply by itself to give you 4? 2. So the square root of 4 is 2. What about b squared? What is the square root of b squared? Just a b. Well done, well done. It's just a b. So now what we're going to do, we make two brackets. One which says a plus 2b, the other one which says a minus 2b, right? So now we are doing it here. So it's going to be 3. There's a bracket which says a plus 2b. Then it is another bracket which says a minus 2b. So you are now done factorizing this one. Are you seeing it? It's dangerous, right? Step number 1 was an ugly one. We started by doing the ugly one. But after doing the ugly one, we remained inside the bracket with things that we could do difference of two squares. Right, Alex? So we had to now use the difference of two squares method. You are seeing it, right? The difference of two squares. So you write that final answer, Alex. 3a plus 2b. Then what? a minus 2b. Can you see it? Have you seen it, Alex? Well done. Let's go now. Alex, what do you do here? What method do we use here, Alex? Is this an ugly one? Are you sure? Can you see this minus? Look, is 9 a square number? Is it? 3 times 3 is 9. So it is a square number, right? Let's write our square numbers. We always should know our square numbers. 1 times 1, 1. 2 times 2, Alex? 4. 3 times 3, 9, yes. 4 times 4? 4 times 4? No, 16. Right? Times 4. What about 5 times 5? 25. Well, 6 times 6? 36. Okay, so it's 49. Then we have now 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. So you should just know them like this. So can I ask you a question? 9, is it a square number? Yes. What about w squared? Is it a square number, Alex, w squared? Yes, it is, because it's w times w. What about 100? Is it a square number? It is what? 10 times 10, right? Well done. So you are going to say, what is the square root of? So that means which method? We don't use the ugly. This is not an ugly one. This is difference of two squares. Can you see that? Because they are the difference of squares. So they say two squares. This is difference of two squares methods. Okay? The first square is 9w squared. The other one is 100. And they are subtracting. You only do it when they are subtracting. Okay, Alex? If they give you something like this and they are adding, don't use difference of two squares. It will be an ugly one when they are adding. We only do difference of two squares when they are subtracting. Okay? Because difference means subtraction. So now what do you do? How do you factorize this? You rewrite 9w squared minus 100. This is going to be equal to, how do you factorize this, Alex? What's the square root of 9? Punch in the calculator. Say square root, then say 9, then say equals. What do you get? Do you see the button which says y to the x? Which calculator do you have? Okay, phone calculator. So square root of 9, what number multiplies by itself to give you 9? What number multiplies by itself to give you 9? 3. Well done. Okay. What about the square root of w squared? It's w. Well done. It's w. You just remove the square. What about the square root of 100? 10. Well done. So now what do we do? Now that we have the square roots, we can make our two famous brackets, right? One which says 3w plus 10. Then the other one which says 3w minus 10. Okay? So are you seeing this one for difference of two squares? Let's look for another one. This is not difference of two squares, right? Because 2 is not a square number. X is not a square number. It should have been x squared. So this is an ugly one, right, Alex? This is an ugly one. So what method do we use to vectorize this? The common factor. Well done. Because if it was difference of two squares, we would have nice square numbers subtracting nicely, right? So, okay, this is not, so we're going to say 2x minus 4x squared. Let's use the common factor method. We first look at the number which is common, right? What number can go into 2 and 4, Alex? 2, well done. What letter can go into x and x? Is there a letter which is common here? X and x squared. Do we have a common letter? It's x. And what is the lowest power which is there? 1 and 2 is just 1, right? So we put x to 1, right? Now let's go. Let's divide. Let's start. What is 2 divided by 2? 1, right? They cancel out. What about x divided by x? It's 1 again, right? So since we just remain with the 1, we just put that 1. Then we say minus. What is 4 divided by 2, Alex? It's 2. What about x squared divided by x? You have 2 of them. You remove 1. What do you remain with? N? All right, so it'll be minus 2x because there are 2, you remain with 1. Okay? There were 2, you remove 1, you remain with 1. Can you see that? Okay. What about here? What about here, Alex? What number can go into 162 and 8? Let's try 1, 2, 3, 4, 5, 6, 7, and 8. 1 is out. Let's start with 2. Can 2 go into 162? Say 162 divided by 2. Do you get a whole number? Divided by 2. All right, good. So we get a whole number, right? What about 8 divided by 2? Do you get a whole number again? Okay, so we may be able to use 2. Let's try with 3 so that we are going to use the bigger one, the biggest of all the ones that work. Let's try 3. Maybe it can get into both. Can 3 go into 8? What is 8 divided by 3? Can it go? Okay. What about 4? Can 4 go into 8? Okay. What about into 162? What's 162 divided by 4? Okay, it can work. It gives you an answer with a comma, right? So 4 is out. What about 162 divided by 5? 5 can't go into 8, so it's out. 6 can't go into 8, it's out. 7 can't go into 8, so it's out. What about 8? What's 162 divided by 8? Okay, so it's out as well. So we can only use 2, right? This is an ugly one, Alex? Can you see that? This is an ugly one, right? Because 162 is not a square number that we know. So we're going to say 162 minus 8t squared. We factor out a 2. What do you remain with? Because there's no letter which is common, so we just factor out a 2 only. What's 162 divided by 2? It's 81. Well done. Then you say minus. What is 8 divided by 2? 4. Do we have anything to divide t squared? No. So it comes as t squared. Well done. Now what is the next step here? Can you just see if it's your final answer? Maybe you're done. But if you look inside this bracket, what do you see, Alex? Yes, you see some squares there. 81 is 9 times 9, right? It's there on the square numbers, right? 4 is 2 times 2, is there on the square numbers. T squared is t times t. So this is difference of 2 squares. Can you see that they're also subtracting? All right, so what is now this 81 squared? What is the square root of 81? What do you get? Square root of 81. Put it in the calculator. So yes, here it's going to be 2, but what is the square root of 81? 2 outside the bracket. But what is the square root of 81? We want to factorize this one, Alex, because this is difference of 2 squares. Can you see that this is difference of 2 squares? Okay, I like that. I like that you can see that this is difference of 2 squares. So let's use the method we use on difference of 2 squares. How do you do it? What is the square root of 81? What number multiplies by itself to give you 81? 9. Correct, right? What about what number multiplies by itself to give you 4? 2. Well done. What about t? What number multiplies by itself to give you t squared? It's a t. All right, good. So it's a t, the number which multiplies, so it's a t. You just remove the squared. So we have 9, we have 2, and we have t, right? What do we do, Alex, when we are doing difference of 2 squares? When we have found these numbers, what do? We make 2 brackets, right? One way it says 9 plus 2t, and another one where it says what? 9 minus 2t, right? Everything fine? Okay, so this 2 was already there, so we don't throw it away. So this 2 was already there. Then you're going to say, all right. 9 plus 2t multiplying 9 minus 2t. Okay, now we can do, I'm just going to give you questions. So I'm going to give you some ugly ones to do, these method number ones. Then when we are back, we're going to now be doing these ones where it's 4, right? And the quadratic trinomials. So far, we've been doing, let's do this last one. We've been doing 2 types, We've been doing ugly ones, and we've been doing this one as well. Is this an ugly one, Alex? Look, if we look, is 4 a square number? What number? Let's list the square numbers. Multiply 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. So 4 is a square number, okay. What about p squared? Is it a square number? Yes, it is, right? Because you get it when you say p times p. Yes, well done. What about 9? Is 9 a square number as well? So all of them are square numbers, right? 4 is there, 9 is there. So, and they are subtracting, right? So this is difference of 2 squares. This is not an ugly one, right? So this is difference of 2 squares. So let's multiply, let's factorize the way we know for difference of 2 squares. We rewrite it. It's 4p squared minus 9. Here we don't look for a number which is common or a letter which is common, because you never find them. But what do? You square root of 4. What is the square root of 4, Alex? 2. Well done. What is the square root of p squared? P. Well done. What is the square root of 9? 3. Well done. So now you make your brackets. The first one should say 2p plus 3, right? Then the second one should say 2p, then what? Minus 3, right? Minus this 3. All right. So can you see that? So you write 2p plus 3, then multiplying 2p minus 3. You've seen? All right. So now I want to give you questions to go and do, right? Are you ready? Let's write them. Write this one. Question number 1. Factorisation. So I want you to write exercise. Write this to say exercise 1. And I want you to say factorize the following. Oh, this is exercise 2. Say factorize the following. Are you doing? I want you to say factorize the following. Then write number 1, 14x minus 21y. This one. Have you done? Have you written the number 1? Okay, now write number 2. Put this one. So this is number 1. Did you put number 2, 9t squared minus u squared? Okay. Can you put this as number 3, please? 4x squared minus 8xy. Put it as your number 3, please. Okay. Can you go down? Let's find another one. Can you say number 4, Alex? Y minus 2x squared, you've written it. Okay. Can you put this as your number 5? We are almost done. Put this as your number 5. Okay. Can you see number 5? Are you sure? Yes. Yes. 2t squared minus this. You wrote it? Okay, so first do those 5 for me. Then we'll meet and we'll continue, right? Say and send me. I'm going to send you the link to submit. Send it in the Google Classroom as soon as you're done. I want 100%, right? Okay, great. So we will be having time, definitely. That's great. So do it and then send it to me. Then we're gonna go through it. Okay. All right. So you take a bit of go for your lunch break. Enjoy yourself. Then we'll meet after lunch. Okay. I'll send you a link. All right. Cheers, Alex. Bye for now.